Hello, this is Gurumurthy Ramachandran, and in this unit, I will be describing a piece of software called EASS version 21, which stands for the Exposure Assessment Strategy Simulator. The software was developed by Dr. Paul Hewitt, who is an independent consultant, but who worked for NIOSH for many years before retiring. The website from which this software can be downloaded is also listed on this page. So when you open the software, you will see this tile of options. There are 6 different strategies that you can simulate and study its performance. So what we'll do is in this unit, I'm just going to talk about 3 of the strategies: the OSHA inspector strategy. What we'll do in this unit is just 2 of the strategies: the OSHA inspector strategy and the AIHA SEG strategy. So let's just click on the first one, the OSHA inspector strategy. And so you'll see several things here. On the top left-hand corner, you'll see a graph that is called a performance curve. And on the x-axis, you will see an individual exceedance fraction, meaning the probability of an individual's exposure profile exceeding the occupational exposure limit. And what is listed on the left-hand side of the vertical axis is called P acceptable, which stands for the probability that the strategy will deem an exposure to be acceptable. And so, for example, if we look at on the x-axis an individual exceedance fraction of 0.25, meaning 25% of the exposures faced by a worker exceed the OEL, then we go to the curve and then read off, and it basically shows somewhere around 75% of the time the strategy will deem an exposure to be acceptable. If you look from that point on, from the 75% mark up to the top of the curve, which is 100%, so the difference is 25%. That is called the power of the strategy, meaning that the strategy has only a 25% power to detect a clearly unacceptable exposure scenario, meaning an exceedance fraction of 25%. And on the y-axis is the average number of measurements. In the case of the OSHA strategy, the average number of measurements is just one. One measurement is enough to detect, or one measurement is enough to make a decision. So let's just quickly go over the OSHA inspector strategy. The OSHA inspector selects an exposure group, identifies 1 or more employees, but it's typically 1 or at best 2, and collects 1 measurement from each. And there's no statistical analysis required. Each measurement is directly compared to the PEL, permissible exposure limit. And the data interpretation is as follows. If each concentration is less than the PEL, then the exposure profile appears acceptable. If any concentration is greater than the PEL, then you need to investigate and take appropriate action. What we'll do is we'll pick a geometric standard deviation for the underlying worker's exposure profile, and we have just picked a GST of 2.5, and we're looking at individual exposure profiles and not group. And in the number of simulations, there is an option that goes from 5 all the way up to 10,000, and so let's just pick 10,000 because it doesn't cost us anything to have a very large simulation size. Most modern laptops can do these calculations very rapidly. We'll assume that the OEL is 1 and um, and the number of measurements we are setting it to be 1. And are we using the 95% upper confidence limit? No, because there is no statistical test here. We are just comparing each measurement individually against the exposure limit. And so let's start the simulation. And we see this is the performance curve. And since the strategy is based on typically one measurement at best, and we have set the number of measurements to be 1, so it is based on one measurement. The performance curve is essentially a straight line. So, for example, 25% exceedance, that means that 25% of the time the measurements are going to exceed the exposure limit, which means 75% of the time they will not be exceeding, they are below the exposure limit. And so 75% of the time the strategy will say that it is an acceptable exposure profile. The exposures are acceptable for this particular scenario. So clearly, for the vast majority of the time, a clearly unacceptable exposure profile, defined in this case as a 25% exceedance, is being deemed to be acceptable. Clearly not such a great strategy. Now let's close this strategy out and instead look at the AIHA seg strategy. So here again, I'm going to now, let's just look at the description of the strategy. So we first select an SEG and randomly select 6 to 10 measurements and collect one measurement from each worker. So randomly select 6 to 10 workers and collect one measurement from each worker. And we then estimate the upper percentile, and we then estimate an upper percentile such as the 95th percentile of the similar exposure group and its upper confidence limit. And if the upper percentile, the 95th percentile, is less than the OEL, then the work environment appears acceptable. If the upper percentile is greater than the OEL, then it is unacceptable, and then we need to investigate and take appropriate action. And if the upper confidence level is less than the OEL, then the work environment is acceptable with X% of confidence. So now again, we have to set the number of workers. So we are setting it first at the minimum that is required by the AIHA strategy. So that's 6 workers. We are setting the GSD of the underlying exposure profile to be 2.5. And then there is a parameter called rho, which is the ratio of the between worker variability to the sum of the between and within worker variability. So it's the ratio of the between worker variability to the total variability. And the geometric standard deviation of the within worker variability is 2.27, and the geometric standard deviation of the between worker variability is 1.51. And as we can see, the GST of the within worker variability is much greater than the GST of the between worker variability. So we can conclude from this, and also from the rho value, which is the ratio of the within worker variability, the ratio of the between worker variability to total variability. And that turns out to be 2. Rho, which is the ratio of the between worker variability to the total variability, is 0.2, which means that this is a relatively homogeneous group of workers. The parameter rho is called the homogeneity coefficient. So let's just run the simulation with a simulation size of 100. And we can see there is a jagged look to the curve, and so we can increase our simulation size to 1000. Run it again. It is still it's a much smoother curve, and when we run it at 10,000 we get a really smooth curve. And so what we are doing in this is that we obtain 6 samples 10,000 times each for each of these group exceedance fractions, and then find out how many of those times the strategy deems an exposure to be acceptable. So now let's look at, again, a clearly unacceptable group exceedance fraction of 0.25. And here we can see now that the strategy deems it to be acceptable less than 10% of the time, maybe 8% or so of the time, which means that this has a power of the inverse of that, or the converse of that, meaning 100 minus around 8%, so 92%. So it has a power of 92% to detect a clearly unacceptable profile of 0.25. And so this is, if you remember, the OSHA strategy had a power of only around 25% to detect a clearly unacceptable profile, whereas this has a power of 92%. So this is a much better strategy at detecting clearly unacceptable profiles. Now let's do another calculation where we now increase the number of workers from 6 all the way to 10, and run the simulation again. So now we see, again, looking at the 0.25 group exceedance fraction point. Now the probability of declaring a clearly unacceptable profile as acceptable is much lower. It's almost close to zero, maybe 2 or 3%. So there is a 97% power of this strategy with 10 measurements to detect a clearly unacceptable exposure profile. And you can use this software and explore it with different values of GST, all the way up to from 1.5 to 2 to 5, and change the heterogeneity coefficient from very homogeneous, close to from 0.05 all the way up to 0.95. So very, very heterogeneous profiles.